In this lesson, we are going to be looking at a third form of the equation of a line. It's called point-slope form. Point-slope form is a tool that we are going to use. It's going to be able to find the equation of a line when we know the slope of a line and we know a point on the line other than the y-intercept. So we're going to use the slope formula that you see here, and simply by cross multiplying we get point slope form. And so let me show you how slope point form works. Basically, a reminder, it's a tool. We use this form in order to get to slope intercept form, which is our y equals mx plus b, or our general form ax plus by plus c equals 0. So it's a tool to get us there when we know the slope and a point. For example, here's a slope 3, and it goes through this point. It's not the y-intercept. So I couldn't write this y equals mx plus b. I actually could use my input-output, find b, but let's use point-slope form. It's y minus y1 equals m times x minus x1. So what I need to do is I need to insert my 3 in place of m. Now the slope between any 2 points is 3 over 1 in the ratio of 3 over 1. It could be 6 over 2, etc. So I use an arbitrary point, x, y. And the slope between these 2 points will always be 3. So now I go y2 minus y1. y2 is my general y from any other point on the line. Subtract y1. When it's subtract a negative, I just write it as plus. Same with the x. The second x minus the first x. And so we've inserted our point of negative 4 for y and 2 for x and our slope. From here we distribute our 3 in, and now we have our way to go into general form or y-intercept form. This right here is slope point form. I will never leave my answer like that, but it's a tool to get me to general form, where I'd move everything to the left, collecting like terms, and making sure the first term is positive by changing all the signs like we did in previous lessons. And then I have my general form, and that's general form. Or if I wanted my answer in slope-intercept form, from there I would have just isolated y. And I would have moved everything over to the left side of the equation, or the right side of the equation, collected like terms, and now I have slope-intercept form. So let's practice a few more other types of examples in which we're using point-slope form. Let's try this one in which our slope is a fraction, 2 over 3. So we are going to use our slope point form. We're going to insert our slope for m. The slope between my one arbitrary point and the point I know will be y minus y over x minus x. But now I don't want to distribute a fraction in. I could, but sometimes it doesn't cancel nicely like it's going to. So what I do is I say, well, it's an equation. Can't I just multiply the left side by the denominator and the right side by the denominator? Because what happens on the right side is my 3's cancel. And since they cancel, I just have 3y plus 12 equals, and only the numerator needs to multiply in now because the 3's have canceled on the right side. I want the answer in general form, so I move everything to the left-hand side. And collecting like terms. And oops, my x is positive. Let's do one last little change. And now I have general form using a point and the slope of a line. What happens if I just give you the equation? Well, first I would look for my y-intercept. If it was obvious or clear, I would say, oh, just go y equals mx plus b. But it's not clear. So what I'm going to do then is I'm going to just find two clear points. Well, I see one there and I see one there. I need, in order to find the equation of a line, I need the slope. Rise over run. 4 over 3. Check. Oh, it's rising left to right, so it's positive. If it was falling, it would be negative. Now I need a point. Any point. I have lots of options. These are the only two clear ones I see. I'd have to keep going over 3 up 4 to get a clear point. But let's choose 1, 2, 3 here. And everything would be the same. I would use y minus y equals 4/3 x minus x. Oh, I have a fraction. Let's multiply both sides by 3. Oh, the 3's cancel. Keep going. 3y minus 9 equals 4x minus 8. Oh, I want it in slope-intercept form. Isolate the y. So I add 9 to both sides. Divide everything by 3. And now I can see in slope-intercept form, my y-intercept is 1/3, and my slope is 4 over 3x. Sometimes I only give you 2 points. I don't give you the graph, but it's really the same thing. You need slope and you need a point. You could graph and count the slope, or you could use your slope formula. The second y minus the first y over the second x minus the first x. Whenever it's subtract negative, I write it as addition. And you get -1 over 3. Always reduce your slope to lowest terms. And if your slope has a negative, leave the negative in the numerator. If your slope had 2 negatives, it would become a positive. Which point should I take now? It doesn't matter. Pick either point. I just need one point on a line and an arbitrary point on the line to create a consistent slope of -1/3 between any 2 points on the line. And I would continue as normal. My y2 minus y1 should equal my slope multiplied by my x2 minus, minus a negative becomes addition, x1. Multiply both sides by 3. The 3's will cancel, and then you will get 3y minus 3 equals, make sure you're multiplying in a negative this time, be careful, -x minus 2, and then check the form that they want it in. We want to move everything to the left because it's general form. -3 plus 2 equals 0, collecting like terms. And there you go. You have found the equation of a line in general form using a point and the slope. Last little piece. What if I gave you point form slope? Would you be able just to tell me a point and the slope of the line? And then use that to graph? Absolutely. Your slope is the number in front of the brackets. In this case, it's -1. Your point is the number you inserted into your formula. So y2 or y1 is this number. It's subtraction, so you just take the 2. Your y value of your point is the 2. The x value is a little bit more difficult. Because it says 7 there, you can't just take 7 because it says subtract x1. So what would this be? Well, how do you rewrite addition as subtraction? Subtract a negative. It's always going to be, if it's addition, it's going to be subtraction, or it's going to be a -7. So the point is -7, 2 with this slope. Would you be able to graph with that? Absolutely. You would plot. You would plot -7, 2 as your point. You always count points from the origin. And your slope of -1, or as a fraction, -1 over 1, your slope is always counted from a point on the line. That would be this one. Okay, so I would go down 1, right 1, down 1, right 1. I don't have the best graph here, but we get the idea. All right?